go through this pretty quickly so we can make sure to have time for the homework. So measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. And I'll explain what that means. Intercepted arc. So what that means is when you have an inscribed angle, so here the angle goes all the way across the circle. This is your intercepted arc right here. And the angle measure here is 1/2 of the arc measure. So let's say this is 140 degrees. The angle measure is 1/2 of that, so this would be 70 degrees. So for these problems, you're either like multiplying by 2 to find this arc or dividing by 2 to find the angle. Okay, and this one here is a similar idea. It looks like triangles, but how you really want to look at it is actually 2 angles. There's an angle here with an intercepted arc right here, and then there is another angle with the same intercepted arc, and when that happens, the 2 angle measures are the same. Okay, and on the back of this, for this theorem, we'll fill in the words in a second. But what this is saying is if you have an inscribed triangle and one of the sides of the triangle are the diameter, then it has to be a right triangle. So this has to be 90 degrees. So if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle. And the angle opposite, the diameter, is the right angle. And the last idea for today is the inscribed quadrilateral theorem. What this has to do with is angle measures. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So when you have an inscribed quadrilateral, the opposite angles are supplementary, so like angle F plus angle D equals 180 degrees. And E and G, angle E plus angle G equals 180 degrees. Okay, and then we're going to move over to 10.4. There's only one page today. Okay, moving over, once you got that down, 10.4. Okay, so the first set of problems has to do with inscribed angle. I'm actually going to cut the lights so you can use them. Okay, so with an inscribed angle, just so we have a reference, we just looked at this, but when you have an inscribed angle in a circle that goes all the way across, let's say this is 140 degrees, like the arc is 140, the angle is 1/2 of that, which is 70 degrees. So with these problems, I'm going to zoom in. Oh gosh, it takes forever to focus. Okay, so first one, number 1, it says measure of angle A right here. Well, the arc is 84, so this would be 1/2 of that. 84 divided by 2 is 42. So measure of angle A, 42 degrees. Okay, and then it asks for measure of angle G right here. So it would be this arc measure divided by 2 would give us this angle, but unfortunately they didn't tell us that arc measure. However, the arc all the way around the circle is 360, so we can subtract these 2 arcs to find this arc. So minus 70 minus 120, and it comes out to 170. So this arc is 170, and then to find the measure of angle G, just divide it by 2, 85. Number 3, they want to know the measure of angle N, this little angle right here. We need to find this arc measure and then divide it by 2 to get this. They show a diameter here, so all of this would be 180. You can do 180 minus 160 to get 20, so the arc is 20. And then divide it by 2 to get the angle, so 20 divided by 2 is 10 degrees. Number 4, they take it easy on us. What is the measure of arc RS? They show the inscribed angle is 67. So we just need to do 67 times 2, which is 134. Okay, I'm going to skip a couple here. We're going to go to 7 and 8. 7 and 8 are the ones where you have inscribed angles with the same intercepted arc. So it asks for the measure of EHF. And it gives us another angle right here, and this angle has the same intercepted arc. So to find this arc, you could do 51 times 2, 102 degrees, divided by 2 to get this angle would be 51, which makes sense because these two angles should be the same measure. So 51 degrees. This one, it says the measure of arc PS right here. Again, you have two angles with the same intercepted arc. But it shows the inscribed angle for PS is 40 degrees, so you can just multiply that by 2 to get 80. So 40 times 2, 80 degrees for PS. Okay, next set of problems. Okay, there's two different things going on here. Oh, something happened to the printing there. Oh, well. Over here we have inscribed quadrilateral. So for inscribed quads, opposite angles, supplementary. So that means like angle Q plus angle X should equal 180. So 95 plus Y equals 180. So this is 85. And then these two add to 180. So 80 plus X equals 180. X equals 100. Okay. Is that right? Yeah. 85, because 95 plus 85 would equal 180. It's 85. Oh. Oh. I mean, once you've done it on paper, you can kind of just do it in a calculator if you were to see this on a screen. Okay, 11 puts both this and this stuff up top together. So for this, let's see, we have an inscribed angle right here, and then the intercepted arc right here. So we should be able to multiply this by 2 to get this arc, or take this arc divided by 2 to get this. So we could say like 2 of these equals this arc measure, but we need to find that arc measure. So it gives us all the way around except for that part. So I can do 360 minus 54 minus 130 minus 110 to find the missing arc right here. And it comes out to 66 degrees. So this is 66 degrees. And then 2 of these would equal this measure. So 2, 3a equals 54 plus 66. And then a equals 20. Then to find 4b, we're going to do something similar. So here is our angle here, and our intercepted arc is all of this. So 2 4b's equals all of this. So 2 4b equals 66 plus 110. Okay, next. Okay, last concept. If you have a circle and an inscribed triangle, if this side is the diameter, then it's a right triangle. So that's what they're showing here. So based on that, then this has to be a 90-degree angle, so y has to equal 90 degrees. Then to find x, just 180 minus 27 minus 90 would give us 63. So x equals 63 degrees. And for some reason, number 12, it didn't print well on mine. Okay, I believe it says 3x right here, and then 34 for this angle here. Okay, so because this is the diameter of the circle, this has to be a 90-degree angle, so 3x equals 90, x equals 30, and then to find this part, the 2y, let's see, 34 plus 90 plus 2y equals 180. Y equals 28. Okay, that's it all. So your to-do list is homework 10-4 on Schoology, and then finish your weekly Alex. We don't have the laptops today, so you'll use your phone. I have a few laptops up here, if the phones. Yes.